Today is our final math lesson. It will be covering page 194 and it is on applications of probability. Question 1 is about Tanya and Daniel who play a game of chance with the spinner shown. So this is the spinner that they're playing with. If it lands on yellow, Tanya wins. If it lands on red, Daniel wins. So question A says Tanya and Daniel play the game 20 times. How many times would you expect the spinner to land on red? So this is kind of using that theoretical probability to come up with your expected number. So we would need what's the proportion of red out of the whole spinner, and then what is that fraction out of 20. For part B, when Tanya and Daniel play the game, they get the results shown in the chart. Daniel says the game is not fair. Is he right? So, if you look at the results, they probably don't match the probability, right? And so the question is it fair that it doesn't match, right? That the experimental probability doesn't match the theoretical probability? Well, it's still technically fair. It just didn't go his way because it's chance, right? But that's something that you could explain. You would probably expect this to look a little bit different. Question 2 is about Janice, who has 2 dice. One has 4 vertices marked 1 to 4. This is the tetrahedral dice. And the other is an 8-sided die marked 1 to 8. So part A asks you to make a T-table listing all the outcomes for rolling the 2 dice. So you could have one column, right, that is die number 1, and one that's die number 2. And then you could put your combinations, right? So I won't do all of them, but if you got a 1 on the first die, you could get 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, 1 and 8. And then you could get a 2 and 1 and keep going on from there. So you put all the possibilities. So I have not finished this first question. You'd have to go through the rest of that. Then it asks you to circle all the outcomes that add to 5. So as we look at this list, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. Okay, well we could circle that one. 1 plus 5 is 6, 7, 8, 9, 3. So go through and circle all of the parts, all of the outcomes that add to 5. Part C asks what's the probability of rolling a pair of numbers that add to 5. So basically, how many outcomes did you circle out of the total number of outcomes? And D, if you roll the die 40 times, how many times would you expect to roll a pair of numbers that add up to 5? So you've got your theoretical probability from question C, and then what is that fraction of 40 for your experimental expected probability? The third question talks about Jo, who has 3 bills in her pocket, a 5, a 10, and a 50, and she pulls out 2 bills. So part A asks what are all the possible combinations of 2 bills that she could pull out. So you can choose how to do this. You could write out a list. Sometimes I still do tree diagrams, but they'd have to be separate diagrams, right? Like I could have a 5, and once I pulled out a 5, my second one I could pull out either a 10 or a 50. Or the first one I could pull out is a 10, and then I could pull out a 5 or a 50. And finally I could pull out a 50 first, and then pull out a 5 or a 10. So these are 3 separate diagrams to show those combinations. So there are 6 combinations, and you could write those out. B asks, would Jo expect to pull a pair of bills that add up to 15? Are the chances likely or unlikely? So if we look at our list, you could circle how many options add up to 15, right? And so how many is that out of it? Is it likely or unlikely? And C is how did you solve the problem in part B? Did you use a list, a picture, a calculation, right? I've used kind of a diagram with a tree diagram and then circling it and then calculating it as well. So I would have like a picture and a calculation. You might have a list or something different. Question 4 starts with Simone. So she made an organized list to find all possible outcomes for rolling 2 regular dice. The table shows part of the chart she made. So this is not the entire chart. This is just if the first die is 1 and the second die is 2s. She would still have to do all the 3s, all the 4s, all the 5s, all the 6s for that column. Why did Simone write the number 1 6 times in her chart and complete Simone's chart? So why did she write it 6 times? Well, what does she have it matching up with on the other die, right? And then you in your notebook can finish the chart. Question 5 asks you to suppose you roll 2 regular dice. So regular dice are 6-sided dice numbered 1 to 6. What is the probability of rolling a total of 4? So you could look at your chart that you make and go, okay, well, 1 and 3 add up to 4, 2 and 2 add up to 4. You could add all the other combinations that add up to 4, and then out of how many total possible combinations. And then you would do the same thing for 6, 7, 11, and 12. So if I were to finish off 4 for you, right, I could have 1 and 3, 2 and 2. I could have 3 and 1. I can't have 4 and 0. And once I get to 5, I can't have any of them. So it would be 3 options out of, my guess is in total there's going to be 36 because our first set of branches would be 6 and our second is 6. So 6 times 6 is 36. And I could divide those both by 3. So that gives me 1 out of 12. So then you can follow along doing those steps for 6 through 12. Well, the rest of the questions. Part B asks what's the probability of rolling an even number total. So when you add it up, getting an even number. So you might have to look at what it is when you add them up, whether half of them create even numbers or not. C is what totals are you least likely to roll? Oh, sorry, I skipped a little bit of them. 2 even numbers, 2 consecutive numbers. So remember, consecutive numbers would be like 1 and 2, right? 2 and 3, 3 and 4, 4 and 5, right? And it could go in the opposite order too. 2 and 1 would still be consecutive as well, but they're just 2 numbers that are in a row. What totals are you least likely to roll? So when you've added up all of your combinations, you can look and see which answer is the least likely and which totals are the most likely. Finally, you have question 6 that asks which outcome is more likely, A or B. So the situation for A is you roll 2 regular dice and get a total of 12. And B is you toss a coin 3 times and get 3 heads. So you could, right, figure out the probability for each of these and then see which one is more likely. Once you have finished this math lesson, you will have accomplished all of the work for all of the curriculum for grade 7 math. So as I mentioned, when we were in school, our jump math books try to cover curriculum for all of Canada, but not all of it is specific to BC. So this will give you all the foundations to make sure that you are ready for next year. However, over the summer, if you want to keep up your math skills, you are more than welcome to go back through 7.1 and 7.2 and fill in the rest of those pages that we skipped over. Sometimes there'll be more review building up to the ideas, sometimes there'll be different concepts. So that is a tool that you could use over the summer if you like. But congratulations, you did it!